We are told that we have 1,000 milliliters of D5LR was to infuse in 8 hours at a rate of 31 drops per minute. The drop factor of the tubing is 15 drops per milliliter. After 4 hours, you notice that 700 milliliters of fluid is left in the IV. And that raises a red flag immediately, because if we're supposed to give 1,000 mLs in 8 hours, after half the time has gone by, we would expect to only have half the fluid left. So we know it wasn't infusing at the correct rate, and we need to recalculate a new rate to get that same amount of fluid in a shorter period of time. So what will be the new rate necessary to infuse the solution in the time prescribed? When we are solving for an IV rate that has a drop factor, we know that our answer will be in drops per minute. That's where we're starting. Our first fraction needs to have drops in the numerator in the top part. We know that our drop factor is 15 drops per 1 ml. mLs must be in the top of the next fraction. We have 700 mLs. That is supposed to be given in 4 hours. Now our answer is supposed to have minutes, so we need to put a conversion factor. Hours must be in the numerator. So we have 1 hour is equal to 60 minutes. We're going to cross out the repeating labels. We've got hours here and hours here, milliliters here and milliliters here, and we are left with drops per minute, which is perfect. That's where you need to be. We are set up correctly. We have 15 times 700 is equal to 10,500. We have 4 times 60, well, really 1 times 4 times 60, and that is equal to 240. When you divide 10,500 by 2,040, your answer is 43.75. However, we need to answer this problem as if we were not giving this fluid via a pump. Some pumps are able to give part of a drop. However, when we are looking at it and regulating the flow by hand, we cannot regulate an IV to give part of a drop. We must round this to a whole number. Because the 7 is 5 or greater, we round up to 44. And our label is drops per minute.